Hello everyone, my name is Viraj and today we'll be looking at the 18th problem from the CP-31 sheet by TLE Eliminators under the 1000 rated questions. Let's go. So moved on to my sheet over here, ticked off 1000 and we'll go to the 18th problem, triangles on a rectangle. Alright, let's read this. A rectangle with its opposite corners 0, 0 and W, H and sides parallel to the axis is drawn on a simple plane. You are given a list of latest points such that each point lies on the side of the rectangle and not on its corner. Also, there are at least 2 points on every side of a rectangle. Your task is to choose 3 points in such that exactly 2 of them belong to the same side and then the area of a triangle formed by them is maximum possible. Print the doubled area of this triangle. It can be shown that the doubled area of any triangle formed by latest points is always an integer. Alright, let's look at the general question. I have drawn a figure over here. That was exactly what was asked in this question. Imagine this is a simple plane. Everyone can imagine a simple XY plane over here, like this direction. This is a rectangle that is drawn where this corner is being named as 0, 0. So you can imagine 0, 0 is the origin. And then this top right corner is actually W, H, where W is the width of this rectangle, like this in horizontal direction. And you can say vertically H is the height of the rectangle. So you can imagine that if this was an XY plane and this was the X axis like this was the Y axis like this, then you can say that W would have been the total distance from 0 to some on the X axis and H would have been the length in the Y direction considering the height of this rectangle. Alright, so this plane, first of all, thing should be very, very clear. Now they are saying is they will give you some latest points, a list of latest points, where these points are going to be placed on the side of the rectangle, not on the corner, which means side means, let's say this is a side. I can say this is the top side. You can say on this side, let's say there's a point like this. Let's say there's a point like this. Let's say there's a point like this. I have done 3 blue points on the top side. Maybe there are points like this, like this, like this. Let's say there are points like this. Let's say there are points like this, this, and this. So they will give you these list of points. We'll see how the input is given, but they will give you this list of points, which will represent these points on the sides. Now they have said that there are at least 2 points on each side. That means I haven't drawn less than 2 points on any side, right? That means I haven't drawn 1 point or no point on each side. Each side has at least 2 points. So greater than or equal to 2. And then the next thing that they have said is they are not on corners. So I'm not considering a point on this corner. I'm only saying they are on the side, somewhere in the middle side. Okay. Now what is the target? This is the diagram that has been given. This is the input that has been given to you. We have been told to pick up 3 points. Exactly 2 of them have to be on the same side and third has to be somewhere else. So let's say I pick up these 2 points. They are on the same side. And let's say I pick up this third point. Now, when I pick up these 3 points, of course, they can be pretentiously joined, right? You can say this is like a joining that has been done by straight lines. This point joins to this, then this, then this. And it's very clearly observable. This is sort of a triangle, right? It's not the case that which triangle are we talking about, isosceles or right angle or anything like that. That's not the idea. Just simply, this is a triangle. Now, for this triangle, there is going to be some area. That means the 3 points we just chose will together create some area for a triangle. And we want the answer of this area to be the largest one possible. That is, out of all such chosen 3 points or combinations of 3 points you could have taken following the conditions, figure out the best area possible and report that to me. To be very specific, we actually don't want to report the area. Rather, we want to report twice of that max area. This is what we want to report. I hope this is clear. All right. So let's take one case so that this becomes very, very clear and imaginative. Let's take the first case and see the input that is given to us. How is that making sense? So first is given W and H. So 5 and 8, that means 5 width of the rectangle, 8 is the height. Then there are given 4 lines next to it. You can differentiate these lines like this to 2 sets of lines basically. In one set, you will be first given the X coordinate systems and then the Y ones. So very clear over here, the line is written, the x coordinates of the points in the ascending order. First line out of this set, for example, let's say I'll take this first line over here, will have all the points which have the line y coordinate as 0 and then the y coordinate is h. And then the first number in this is actually a random k number that is given to us, which we'll have to input, that showcases how many points are there on that line. So for example, if this is written as 2 and then there are 2 points next to it, that means this has y coordinate 0. It has 2 points. I have drawn a figure over here quickly for you so that it's very clear. This is y equals to 0 axis. On that, there is a point 1, 0 and then 2, 0. Similarly, the next line has 3 points, 2, 3, 4, which means y is fixed, that is 8. So 2, 8, 3, 8, 4, 8. Simple. And then let's say the next line. Now this time you have changed the set. You have gone to the set which has vertical points. So now first line of this set showcases x0. That is, you can say 0, 1, 0, 5, 0, 6. Very clear over here. Sorry, I think 0, 4. This is 0, 4, not 0, 5. Okay, so I can rub this out. 0, 4. And then you have the next as 4 and 5, which means 5, 4 and 5, 5. So I have drawn the diagram roughly. This is not true to the exact system sort of a points. So don't worry about that. We just need a right figure to understand what sort of an answer are we achieving. Now for this case, the answer is coming 25. How? Let's quickly observe. They are saying you can take a point 0, 1, 0, 6 and 5, 4. And what will happen now is, let's mark these points, 0, 1, 0, 6 and I think 5, 4 over here. Now if we connect these points, you basically get a triangle that looks like this. If I have to calculate the area of this triangle, we know very simply area is half into base into height of a triangle. And now we want basically 2 into area. So that is simply you want base into height. All right. So what is the base over here? The base is the length of this much. This length is of course 5. Okay, why 5? This is 6, this is 1. So this difference is what we are calculating. So this is 5. And then height of this triangle is going to be total, I think this is 5. Yes, 5 is this width, correct? That is the width of this rectangle that is given to us. So this basically means that I have received 5 into 5 and this gives 25. And now they are arguing this is the best possible. So there's no argument there. And hence we get 25 as an answer. So I've given you a very diagrammatic approach. You can of course pause the video now and draw the other 2 cases also with your pen and paper. And I think you will understand 42 and 35. They'll be very clearly observable. Okay, great. So we have understood the problem. Let's quickly discuss the time complexity ones. We have been given that time limit per test is 2 seconds. And then there is a test case variable. Although we don't need to bother with that because we have been told that the number of points on all the sides do not exceed for all test cases overall do not exceed 2 into 10 raised to 5 order, which means I can compare with this factor 2 into 10 raised to 5 order with 2 seconds. That would roughly give me something like this. If I said one test basically allows me 2 into 10 raised to 8 operations, and I'm looking for n being approximate 2 into 10 raised to 5 order, for example, n or k, the number of points that you talk about. Now, since you have been told that you want to take 3 points out of n, if we look for a solution that is like n square or something above that, that is not going to work. Something like an O of n solution or O of, let's say, lesser than this, probably like maybe log n solution or so on till if you create a constant solution. All of this is going to work, but nothing like this, right? We won't want something like in a square order. Maybe you can create something that looks like even a little larger than this, maybe O of n log n solution also. That is also fine. It might work, but then not above that. Let's again mark across over here. And now why did I did this discussion? This is very important because now I have realized a very important thing. If I look this problem as a very, you can say beginner friendly sort of a problem, you might think that you can take random 3 points out of the total points and just try to make a triangle for yourself and figure out the area. But this is not possible. The possibilities of figuring out 3 points out of the given endpoints is very large. The complexity would be very large. And we have just seen that we need a complexity that isn't crossing such boundaries. So how would you do that? No. That means now I have a very good idea from expected time complexity where to start this problem. I need something better. Great. Let's begin. Now the approach is very intuitive. Let's go back and look at the formula once. We have been told that area or 2 into area is what we're trying to calculate, which is base into height. Okay. Now, if I tell you that you have to maximize product of two numbers, what is your first intuition? Just maximize the numbers. If let's say I increase my base and I also increase my height, knowing that both of these numbers are greater than 0, base is also greater than 0, height is also greater than 0, then of course base into height will go even higher. That's very obvious. Let's say base right now is 4, height is 5. 4 into 5 is 20. Now let's say you increase the base. Base becomes 6. 6 into 5 is 30. Increased or not? Yes. This is a very good starting point. Why? Because let's go back and look at the diagram. I'll just rub all of this out quickly. And let's implement a very important logic over here. If I tell you that you have to create a base of the triangle, what is the best way to do that? You have been told that you want exactly 2 points on the same side, and then the third point should be somewhere else. So it's very imaginative that those 2 points can create a base. For example, if I choose this side, I want to create the base of the triangle that I form from this top side. Now to do that, I have to select 2 points. My question to you is, should you take these 2 points? Or should you take these 2 points? Or should you take these 2 points? Why did I say this like this? Because the very important thing is you want a higher base. That means you overall want the length to be very good. If you want the length to be very good, don't you think it's intuitive that I should take the first point on this side and the last point on this side? Meaning, like right now in this diagram, there are only 3 points. Let's say there had been some 200, 300 points. Which points would you prefer to create a base? If you take the first point and if you would have taken the last point, the overall distance would have been the largest. Any other 2 points will give you a lower distance than this, greedily observable. That means selecting first and last creates a very good base for me. I hope this part is clear. Now I have a base of the triangle ready, which is the largest one possible if I was considering the top side. Now let's talk about height. From these 2 points, if I select a point that is on this side or on this side, you will create a height that looks like this, only up till this much limit, right? Something like a this much limit. But if you take a point on this side, for example, like this, you create a height that is actually equal to the max height that is there in the diagram. That is actually the height of the rectangle. This means that, don't you think it's greedily the best to take a point right on the opposite side of the base that you have created? To be very specific, one idea more. Should I take this point? Should I take this point? Or should I take any other point? It doesn't matter. Why? Because if you have these 2 points fixed and you create a triangle like this, or you create a triangle like this, both triangles have the same base as well as the same height. Remember, height is the perpendicular distance that is created from the base, not something like a slant or something like that order. So don't imagine that if you take this point or any other point, the height changes. No, the height does not change. The triangle's height still remains same, that is h. This is a very neat approach now. Why? Because all I would want to do now is, if I let's say talk about the top side, I would just want to select 2 points. First point as the first in all these points, and then the other point as the last point in all these points. This creates the base, and just multiply that difference with the height of the given rectangle, because I know that the other side does have points that is given in the problem. I know that it has at least 2 points. So there can be some point by which I could have connected and created a height h. And this gives me the best triangle possible with the base on the top side. Now, once I've done this for the top side, I can implement the same idea for this side, and this side. A small corner case on this would be, if you do this for the bottom side, you know it would be almost the same logic. You take the first and the last point, whatever they are, they create your base, and then you multiply this with height. But if I talk about these 2 sides that are vertical sides, now the height doesn't actually look like h. It's a very diagrammatic idea. You can just tilt your head like this and I think it's going to be visible. If you select the first and the last point to maximize your base, that idea still remains same. But what is the height now? The height is not exactly h. Now you're talking about horizontal height, which is actually w. So this will be created as w, hence making sense that, okay, this is how the triangle would come off as. I can write this whole idea once more. What we would finally do is we would make 4 cases. You can say a top case, a bottom case, a left case, and a right case. Top and bottom cases will implement the same, or rather all 4 cases will implement the same idea for calculation of base, but their height of triangles will change. Top and bottom again will have something like a B1, B2, B3, B4 base, where all these B1, B2, B3, B4 are just the differences in the first and the last coordinate, the horizontal or the vertical direction. I think we can implement that, of course, in code piece however we want. But top will be multiplied with h, bottom also with h, left with w, right with w. And this can be termed as the 4 possible A1, A2, A3, A4 answers. Whatever is the max of this creates the overall answer. I hope this part is clear. Let's quickly run this on one of our test cases once more. Let's go back and see this second case. Let's say, for example, what is W and H? 10, H is 7. Let's take the first case. So you want the difference between the first and last point. Now they have also eased out this for you because they gave the points in ascending order all the time. So you don't even have to worry about sorting the points to figure out the first or the lowest and the largest point. You can just take a difference between the first and the last input that you make. So only 2 points over here, 3 and 9. So I think just take 9 minus 3. This creates 6. Then you have 1 and 7, 2 points only. So this is 7 minus 1. This creates 6 again. Now on this is 1, 3, 4. So you can take the first and last point. So this is 4 minus 1. This is 3. And then this is 4, 6, 4, 5, 6. So that is 6 minus 4, first and last. This is 2. Now you multiply 6 into, remember this is height, into height. Now from here, width into width. What is this? 42. What is this? 42. What is this? 30. What is this? 20. Take the max. This turns out to be 42. What's the answer? Yes, answer is 42. So I hope the problem is very, very clear. It's a very simple geometric problem. You could have also seen the tag over here. I hope this clears up most of the idea. Let's look quickly into the code part and see how do we implement this. Just how I showed you a pseudo structure of how we would do things. This is the same thing I would have done in code. I take the input of test case, then W and H. Then I have the area variable, that's the answer variable. Initially it's int min because I want to maximize this. Now I want 4 set of lines as input. So I run a loop from 0 to less than 4. I take first the input of k, that is the k points on a single line. Now I only found the first and the last point. So I just have these 2 variables. I run a loop from 0 to less than k, take the input of each point that comes on a single line and only save the first and last. How do I do that? If j is 0, that means the first point. So let's save first as x. If j is k minus 1, that means this is the last input, last point. So last is x. Now when I come to this loop, I have the first and last initialized and done and dusted. The base is their difference, last minus first. This is valid for all 4 cases. Only the height is a different parameter. Height is h when I is less than equal to 1. Why I is less than equal to 1 means 0, 1. So 0, 1 means the first and second line, which indirectly means that, okay, this is where I'm talking about getting the top and bottom cases. And then else the height is w because this is the left and right cases. And then area variable gets maximized with base into height. And this finally gets printed outside the for loop of 4 size, which gets me the perfect answer. All right. Now, what is the time complexity? 4 order over here to take the 4, set of different triangles, you can say, or 4 cases. Then this is simply a k looping over here. And then I think this is just maxing this out. So everything's pretty much constant. So I can say something like a O of 4 into k, which is roughly like k order only. Now, if I go back and see k was given in 2 into 10 raised to 5 order. So we have actually created a solution that is 2 into 10 raised to 5 order, which is preferred since we already discussed this in the time complexity discussion. And space complexity is pretty much constant. Why constant? Because I'm not using any extra space to store my points. I just have the variables that are quickly doing this for me. So I know space is constant. So this clears the problem. A geometric problem indeed. Pause the video, draw the triangle and the rectangles yourself to realize what sort of a maxed out triangle method am I talking about. And I think this problem is going to quickly hit you. All right. So this is all that is there in this video. I hope you like it. Thank you for watching.